in this chapter we're going to learn quite a few methods of factoring, and the first and most important is that of factoring out a least common or a greatest common factor. When you look at this 24x minus 36, you're supposed to ask what is the largest expression that will go both into 24x and negative 36, and the answer is 12 is. And we're going to divide out the 12 and have 2x minus 3 left over. Notice that you can check this by taking the 12 times the 2x to get to the 24x and the 12 times the minus 3 to get to the minus 36 up above. This is only factored correctly if 12 is the GCF. If you were instead to have factored this and only noticed that 6 came out of both the 24 and the 36 and factored that out and gave you 4x minus 6 inside the parentheses, you might be able to check it and distribute and say yes, 6 times 4 is 24 and 6 times negative 6 makes the negative 36, but this is not correct because 6 is not the GCF. And looking inside the parentheses, seeing the 4 and the 6, you see that they're both even and a 2 remains to be factored out of both the 4 and the 6. You are responsible for factoring out the greatest common factor, the largest expression that goes into both terms. In this second problem which I have here for you, 18x squared minus 18x, we see an 18 in both of the terms. But we also have some x's, and x will go into x squared. And for the occurrence of x, you have x squared versus x. You take the smaller exponent, x to the first, as the GCF. When you divide this out, you are left with x minus 1. And I emphasize the word divide this out. We so often use the phrase factor or take this out. Take sounds like subtraction. We're actually dividing. Notice how 18x divided by 18x makes minus 1. Okay, moving on to problem number 3. We look at the 20 and we look at the 24, and 4 is the largest number that goes into each. Then we look at each variable separately. We have x to the 5th versus x to the 2nd. We choose the smaller of the two, x to the 2nd. For y to the 3rd versus y to the 5th, we take the smaller, y to the 3rd out. And z squared versus z to the 1st, we take z to the 1st out. And I use the word take, and I probably still will, but this is dividing it out. Then we ask, how many times does each of these go into the 20x to the 5th y cubed z squared? The 20 divided by the 4 makes 5. The x to the 5th divided by the x squared makes x to the 3rd. Now I just mentioned division, but you're basically just subtracting exponents, 5 minus 2. With the y's, you're dividing the whole y to the 3rd out, and with the z's, one of the z's is being divided out of the z squared, leaving one z left over. You then move on to the second half of the problem. Negative 24 divided by 4 makes negative 6. The whole x squared divides out. Of the y to the 5th, 3 of those y's divide out, leaving y squared, and the z divides out. Notice inside the parentheses there is no common factor. There's no number that goes into both 5 and 6, and none of the variables are in common, which means we divided out the most we could for that exercise. Number 4. We're looking at 14, 28, and 35, and we notice that 7 goes into each of the 3. X to the 5th versus x to the 7th versus x to the 2nd. X to the 2nd is the smallest. Y to the 3rd, y to the 2nd, y to the 8th. Y to the 2nd is the smallest of those 3. Now we divide that 7x squared y squared out of each of these 3 terms. 14 divided by 7 makes 2. Subtracting exponents, we get x to the 3rd y. 28 divided by 7 is 4, so we have minus 4. Subtracting exponents, 7 minus 2 makes 5, x to the 5th, and the whole y squared divides out. 35 divided by 7 gives us 5 at the beginning of the third term in the parentheses. The whole x squared divides out. Y to the 8th divided by y squared. Subtract the exponents and get y to the 6th. And double check inside, making sure there's nothing that goes into each of these three terms, and the answer here is nothing else does. Moving on to number 5. We see a negative out in front. Now 12 and 4 are both even, but 9 isn't, so 2 cannot be factored out. 9 is divisible by 3, as is 12, but 4 is not divisible by 3, so there's no number that goes into each of these coefficients. Likewise, we've got x's in the first two terms, but no x's in the third term. So no variables can be factored out either. When there's a negative leading coefficient, we factor that negative out, either as a -1 or just the negative, and when we do so, we divide out that negative, which changes the sign of each term inside. Notice how the -12 became a +12, the +4 in the parentheses became a -4, and the -9 in the original expression became a +9 once divided out. So that would be our answer, the answer to the factoring problem. So as a general rule, whenever, I'd like to write this out, whenever there's a leading negative coefficient, it always gets factored out. And that leaves a positive at the beginning of our parentheses, which is what we like for when we get to multi-step factoring problems. So that is the factoring out a least common or greatest common factor method.